All right. Hi, everybody. Good evening. Welcome to the second live session
Good
for
evening.
the course Foundations of R Software. So let me start by sharing my screen. Mm-mm-mm. Okay, share. Okay, you should be able to see my screens now. Okay, so in case any of you had not joined us last week, so I'll just walk you through what you're going to be, how it's going to be arranged. So for the NPTEL course, every week you get a set of lecture videos, and it's a 12-week course, so it's going to be done over 12 weeks. And then on a particular Wednesday, you have assignments to submit for the content that was covered in that week, right? So these live sessions, there are going to be 2 live sessions per week, one on Fridays and one on Tuesdays. And so the idea is to get a recap of what was covered in that week, to discuss a few practice questions, or in this case, there are going to be more commands. And then starting from the next week onwards, we'll also solve the previous week's assignments and see if there was any place where you were stuck. And then if you have any doubts, we'll clear that. So I'll be taking the sessions on Fridays. So today we've already done the session for the first week. Today I'll be talking to you about the content that was covered in the second week. And then 4 days from now, which is on the Tuesday, on the 6th of August, there would be another session for the same week. So in case you still have some doubts, you can attend that session. Otherwise, attending any one of them should suffice. Okay. And yeah, so basically this session is being conducted on Zoom. The session is being recorded and it's going to be uploaded on YouTube. Any material we discuss in this session, which is these presentations or the R scripts, it's going to get uploaded on the Google Drive, and you would have the access to all of this. So this is the NPTEL page, and there's this problem solving session link here. So if you open that and click here to view, so there is this Google Sheet that's shared with all of you. So both of us, so I'm Pallavi Gupta and the other TA is Kamna Mishra. So we would be uploading the links and the presentations here, so you can get back, watch the videos, or download the presentations and scripts and practice. Okay. So last week, which was the first week of this course, we talked about basics of R, how to install R, how to open the software, how to make a script, do simple calculations there. And so before we start the session, do you have any questions from the last week? Or if all's good, then we can just start today's session. And at any point of time, if you have any questions, please feel free to unmute yourselves and ask, or you can put it in the chat box. Either is okay. Okay, so if there are no questions, so let's start with today's session. So before we start, the first and foremost important thing you have to do is install R on your computers or laptops. So this is the link for R. So you can click on any of the available mirrors. It does not matter which country's mirror you choose. Once you do that, you'll get a link to download R for whichever operating system you're on. Click that, follow the installation wizard on your computer. It should be straightforward. The second thing is, which was also discussed in this week, is something called the R Studio. R Studio is another software which uses R, and R Studio has it's more of a graphical user interface. You still have to type all your commands, but it offers a little more functionality, and we'll see that today. So the idea for the remaining weeks, for the live sessions for remaining weeks, is going to be that the lecture videos that you get on NPTEL, they show you the commands on R. I'll be discussing the same commands, like we'll be walking through very similar things, but on RStudio. So you will get an idea to use both of them, and then it's completely on you which of the two you prefer. Okay, none of these are very intensive softwares. We are not going to be dealing with large data here, so you don't have to worry about your computer crashing. Okay, so to install R, this step you've already done, and the second step is to install RStudio. When you open this site, it's automatically going to detect what operating system you have. You just need to install RStudio, and that's it. But yes, first you need to install R and then RStudio. And for Mac users, you will also need something called Xquartz, which just allows images and plots to be made. Okay. Okay. Now, so I don't have a lot in the presentation, so we'll jump on to the R script here. So if you remember the last time we talked about how you can open R. So I'm just going to search for R here. So you can see I have R installed and I also have RStudio installed. So I'm just going to open R for now. So this is what it opens. It shows you what is the version of R that you're using, and give it a minute or so. And here you're going to see a greater than symbol come up. Okay, it's taking its own sweet time to open. In the meantime, if again there's any question, please feel free to ask. Okay, so this has opened. Now we talked about that.
Hello?
Yes,
Yeah,
I can hear you. Yeah.
ma'am, Anaconda, yes, the Anaconda Navigator I have installed, whether it itself having the R Studio, whether we can use it further.
Yes, so I will show you how to use RStudio today. I'm just sort of doing a transition from R to RStudio. And then from the upcoming classes, we'll be using, for these live sessions, I'll be giving you the demo on RStudio. So you'll be able to see its functionality as well.
Okay. Okay.
Okay, yeah. All right. So this is the console. Now there are two things you need to keep in mind, the console and the script. Okay. So console is where you see this greater than symbol, where R is accepting the input from the user, right? So we can type things like 2 plus 3. And when we press enter, you'll see that the output is getting printed. Now we discussed last time also that if you go to file, and depending on what operating system you have, it's either going to give you new document or it can give you new script. Either way, you open that. It's going to open something like a notepad here, right? And here you can start typing. I mean, it has to make sense. So you can start typing the same thing. X is equal to 3, 7 plus 4, or 3 plus 4, and things like that. You can also add comments, right? And then you can execute this or run this command directly. So once you have your cursor here, if you press Control Enter or Command Enter, the command gets moved from here up until it moves to the console directly, and it gets executed there. But you still have a record of what you ran. So this is the basic, these are the two basic things that R needs. It needs the commands. You can directly write them in the console, but then it's difficult to keep a record, right? And if you want to save this, you'll just directly go to you'll go to file, you'll do save as, and then just type in the name of the file. So let's say if I write trial and I'll save it. So it gets saved, and we can check this here. So you can see trial comes up here and says it's an R source file. Okay, so that's pretty straightforward. Now, if I have to open a document, I have made a document for today's class. So I can go to open a document, and I have this, no, sorry, this one, week 2 underscore script, I've called it. So I'm going to open that, and you can see it's a long script that we have for today, about 85 lines. And so we'll just walk through all of this. But now you can, so here I just want to show you what it looks like. So you have something like a notepad here, and then the console is on the left. Now I'm going to close this, and now we are going to switch to RStudio as an example. And just reiterating, RStudio just offers you more convenience. It's not that RStudio gives you any better performance in terms of the functionality, or the commands are faster or anything. So it's just a matter of convenience. So like I said, the demo in your online lectures is in the form of okay, the demo in your online lectures is via R, and here we are going to use RStudio, so you will get an idea how to use both, and so you can choose which one works better for you. Okay, so I have set RStudio as the default for my R files, but either way, you can just open that. Okay, so let me close this and start a new one. Okay, so I'm just going to double click this so it opens in RStudio. And now what you can see in RStudio is there are broadly four sections you can see, or four panes you can see here. So on the top left is your script, the file that I just opened, right? Bottom here is the console that you can see it's highlighted. This is some error in that's particular to my RStudio configuration. I tried installing something, it did not work. But either way, what you can see here, it's pretty much the same thing that you saw in the R console on R, right? So it shows you what version it is. And then finally, you have this greater than symbol coming up, which is what defines a console. And then on the right side, we have two more panes. One is called, it's broadly the environment. And below here, we have something called, there's a lot of things here. So we'll see the functionality of all of this as and when we are progressing through today's script. So I have a few comments added here, which we'll just walk through, just sort of like a revision. So there are these four panes in RStudio. Comments, this is a comment. So whenever a line is beginning with a hash symbol, it means that it's a comment. So R is not going to read it. R is not going to run that, but it's for your reference, because sometimes you'll have such a long command, you would like to remember what each line is doing. R is case sensitive. So a variable small x and a variable capital X are they're considered differently. Our script has this, so whenever you want to run a command or you want to execute a command, you can either press Control Enter, you can highlight that line, or you can have cursor on that line and you can press Control Enter, or there is also this Run button here in RStudio. So this is the additional functionality we're talking about that RStudio offers, but otherwise it's similar. Okay. Spacebar. So it does not matter if you write. So tell me if the font size is okay. So okay, what I can do here is I can press Control Enter, or sorry, Control L, and this console gets cleared up, right? So it's just easier to see. So I'm going to type 2 plus 3. It works. If I write 2 space plus space 3, that also works. So spacebar does not matter. We will see what spacebar within double quotes is. If you want to type a previous command again, you don't need to type it again. When you are in the console, you can just press upper and lower arrow keys, and those commands are going to come up. So you don't have to type that again. Tab, we saw this last time. We'll see again that once you have 3 letters at least written, then RStudio or even R can predict what all options you might have, because a lot of times it's difficult to remember where a capital letter is in a command's name. Okay. So tab key helps. And then suppose you're running a command, suppose it commands like this, they don't even take 1 second to run. But sometimes, and we will see that later in the course, there could be commands which take very long to run, right? Maybe they'll keep running for 2 minutes or 5 minutes. And maybe after 10 or 20 seconds, you realize, oh, you did something wrong, and there's no point in running the entire command. So you can press the escape key, or here you will see there's a stop button that comes up when a command is running. So you can click that and you can interrupt that command which is running. And then Control S to remove everything from the console, which we just did, right? So if I can press Control L again, the command is gone. right? It's still there when I press upper arrows, but I don't see it in the console. So it just clears up the space so that you can start new. Okay. And then we also saw in the last week that there's something called installation of packages. So packages are nothing but a collection of commands. And when we say command in R, it means it's a set of generally words or alphabets followed by a curved bracket. So something like this or something like this. So in R, you are basically going to be running commands. So, they're going to be some commands which not everybody who uses R they use. They could be field specific. So you only install them if you need it, right? There's no point in installing or downloading something very huge and keeping it in your computer when you are not going to use it. So you have installed some packages, but they're not yet ready to use each time you've opened a new R or RStudio window. So you have to load that library, which you load using the library function. So if you remember last time we had this example of tidyverse. So when you're installing, it should ideally be in double quotes. And when you have this the library, you don't need double quotes anymore. So you see here, when I type the first three letters, R automatically gave me what all is there that it's able to think of, what all's already installed. So for me, I just need tidy words right now, so I'm just going to do that. Okay, so this is what we talked about last time. And then we have simple things here. So let's say we can assign a value to a variable, right? So let's just take a few different examples. So you have a small x, you want to assign the value 8 here. So you have two options. You can either use a is equal to symbol, or you can use the assignment operator. And assignment operator is, you can think of it as an arrow which is pointing towards the variable. Okay. And okay, we have more people joining us. Cool. So now I'm going to run these commands. So what is going to happen is I have my cursor here. I'm going to press Control Enter. The command is going to get executed in the console, but I would also like you to keep an eye on what is happening to the environment here. So I run this, and you see here in the environment, an entry is created which says X has the value 8, which is what we did. Now, this is another added functionality that RStudio offers, that you can see what all variables you already have. When you are writing a larger chunk of code, when you have a lot of variables, sometimes it might be difficult to remember what variables you already used or what are the values of those variables at a given time. So to have this open on the right side, it's convenient. Okay. Another way of assigning values is using the assignment operator. So it's doing the same thing. R is case sensitive. So a capital X is going to be a different variable than small x. And we have just assigned a character variable to it, right? So the numbers here, they are called numeric. And the character here, which is in double quotes, it's going to be called character. And then, of course, you can, suppose you want to have one variable assigned to another variable. You want to have like a duplicate created for that. So you can use either of these ways, right? So now you can see, so Z also has the value 8 because that's the value that X held. Okay. Suppose there's another variable you create like this. And so we have one command here coming up, which is called mode. And we just talked about it. Mode is telling us what the kind of variable is. What's the value in that variable? Or rather, I should say, what kind of value is there in the variable? So the two most common values that you will have are numeric or character. Very simple. Okay. And so that's one way of checking. So you get the answer that it's numeric or it's character. Now, if you want to check whether it's numeric, so when you're saying mode, the answer is numeric or character, but you can also check if something is character or not. In that case, when you're checking if it is character, you can either get a yes or a no answer. It it is either a character, so it's true, or if it's not a character, then it's false. So if I run that, if I run a is.character command, so again, this is the name of the command. And then since it's followed by a curved bracket, so you can be sure it's a command. And commands generally take up an input. So inside that bracket, you would have one or more values. These are also called arguments. So inputs or arguments to a command. So now x here, the small x here, that's the value 8, right? So if I'm running is.character, it should give me false, and it is giving me false. Now, can you tell me what this should give? Is.numeric, should it give true? Should it give false? You can put it in the chat. What should be the output of the highlighted line? So, yep, cool. So this should give me true. Now, just a note. So you can see here, this comes up as all uppercase letters. So whether it's calling it true or false. So capital FALSE and capital TRUE, these are reserved words. We'll come across more reserved words as we go on. So as such, your variable names could be anything. You could have called them true and false also, but R understands them differently. Okay. So it's not recommended to name your variables with names that already mean something to R. Okay. Okay. And likewise, so for P, the outputs are going to be opposite because P is a character. So when I run is.character, it's going to give me true. And when I say if it's is.numeric, it would give me false. Okay. Now this is.character. So it's asking you if it is a character or not. Now as.character is asking you to convert it to this form. Okay. So x is a number. It's in the number 8. And we check that x is indeed numeric, right? So it truly is numeric. Now, if I convert a number to a character, can you think of what might happen? Would it work? Would it not work? Like, would it give an error or would it give some output? If it gives an output, what do you think the output is? Any guesses are okay. There's no, I mean, it's sort of just on you. You can just make a guess. What do you think would happen? If I'm saying that convert the number 8 into a character, what do you think might happen? Come on. Give it a try. Nobody wants to guess. It will give a warning message. That's a good guess, but this answer is correct. So 8 in double quotes. Okay. So you can see here, it worked. It did not give a warning message. Although, you got a warning message. So ideally, it should not give you a warning message. Okay. So let's try the other command. So there are two options that you can do. You are converting a number to a character. And the other thing that we are doing is we are converting a character to a number or character to numeric. So if we are converting NPTEL to a number, when we do that, then it gives us NA and it gives that warning message that you just talked about. Okay. So think about it. A number, you can always write it in double quotes and it becomes a character. So for example, when you're writing your address, okay, when you're writing your residential address, there are numbers in that as well, right? Let's say flat number or room number. You're writing these numbers. But as such, the address as a whole, it's a character string. Okay, it's not just a number. You cannot do mathematical operations on that address. But there are still numbers inside it. So those numbers are written in double quotes. But on the other hand, when you have a phone number or when you're doing mathematical operations, simple calculation maths, you don't have alphabets in them, right? You cannot add a plus b unless a and b have some value. Okay, so converting a number to a character is doable, which we just saw, but converting a character to a number does not make sense. So which is why it gives you NA, but it also gives you a warning message that, well, this NA does not make sense. NA is a null sort of a thing. We'll discuss a bit more on what NA means a little later, but NA is basically something that's non-existent, something that does not make sense. Okay, all right. And then there are a few more things that you can check. So you can check if a certain number is finite, if a certain number is infinite. Okay. So again, is dot finite. So you're questioning if it is of that form or not. So the output you get is true or false. So capital X here is, it's actually, I've changed it to A. So let's see what it gives. So a character here gives false for both, if it's finite and if it's infinite. Okay. On the other hand, if I had small x here, which was the number 8, then when I say if it is finite, it's going to give me true. And if I say if it is infinite, it will give false because 8 is not infinite. Okay, and then we just talked about this NA value. So NA is, it's often important to check that your numbers are not NA. Okay, here you can already see that you just have one value and it is not NA evidently. So checking this is not very relevant. Yes, that's a good question. So let's try. So before we do that, so is.na, it just gives false here. Okay, so your question was, so let's try is dot finite 1 by 0, and the other option is dot infinite to 1 by 0. Okay, so is dot finite, it says it's false, and 1 by 0, it gives it infinite. So is infinite, it gives true. All right, so that's a good question. Okay, good. All right. So these are some basic checks that very often you should do whenever you're getting a data from somebody else. Here we have defined our variables, so we know what the variables are. But let's say if somebody has given you an Excel file and you are doing something from that data, which eventually throughout this course we will talk about all of those things. So whenever you have a lot of data which you cannot manually check each and every value, if there is a value there, if there is a number there. So these checks are important. Okay. Um, all right. So this is something we discussed quite in detail the last time that you have. So if you remember from maths, again, we're not going into a lot of detail right now, but there are broadly two things, scalar and vector. So scalar is a single value, okay, that we've been seeing up until now. Whether that single value is a number or the single value is a character, it's a single value. So we call it scalar. And then you can also have vectors. So in different languages, vectors are called by different names. You might have heard something like an array. Okay. So vector is a sequence of scalars in a way. Now that sequence can be numbers, the sequence can be characters, or that sequence can be a mix of both. All right. So so anyway, so when you're doing scalars, let's talk about scalars as numbers. So you can do addition, subtraction, multiplication, division, power. Um, so addition is simple. You have the plus sign. Subtraction is the minus sign. Multiplication is the asterisk, which is above the number 8. Division is the forward slash. So let me just write this here. So if it's 2 plus 3, 2 minus 3, 2 divided by 3, yeah, and 2 multiplied by 3, like that. Okay. So you can run all of this. And of course, these values are what you would expect. When you have to do a power or an exponential, there are two ways of doing it. One is this caret symbol, which is above the key 6 on the keyboard. And you can also do a double asterisk. Both of them, so 2 to the power 3 is 8. And both of these notations, they both give you 8. Okay, so again, it's again a matter of preference, which one you like better, but it's also very easy to get confused. Okay. And if you have a lot of mathematical operators in one line, then BODMAS is going to get followed. Okay, so bracket, order, so the power, and then division, multiplication, addition, subtraction. And you will see that there are questions like these in today's, like this week's assignment. So we'll practice a couple of them at the end of the class. Okay, and then you have vectors. So like we said, vectors are a set of, there are multiple scalars, one after the other. And there are a few different ways of, so let me give you another example. Mm, 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 mm. Okay, so bear with me for a minute. So the first way, which is the most common way of defining vectors, is the command C. So C is just short, it stands for combined. So what you're doing is you are actually specifying each of your inputs here. So you're saying the first input is 2, the second element is 6, third is 5, so on and so forth. So if I run this, so again, what I'm doing is I'm assigning this vector to the variable L. So my variable L here gets made. Now you can see it's written a bit differently here. It says it's numeric already. So it's NUM is short for numeric. It says that there are, so if you remember the square bracket here, square bracket is used to define positions. For example, here you can see in all the outputs that we've seen so far, since there's just one element, the line is starting with the first element, of course, right? So there's nothing great about that. But here you can see that you have 1:8. So it's telling you that there are 8 elements in this vector. Likewise, we can also have a character vector. So I'm defining this one, same function. It's just that now each element is enclosed in double quotes. So we have that here. So you can see K. Now you can see CHR stands, it's the short for character. And there are 6 elements in this. And these are the 6 elements. Great. Now there's one more way in which you can make a vector. So suppose it's a continuous vector, whether it's increasing or decreasing order, but it's an increment or decrement of 1. So you can have it like a colon. So 1:4. So if I run that, so you can see here, it's just to simplify it, let's say if it's 3 to 6. Okay, so you have there are 4 numbers here, 3, 4, 5, 6, and they're assigned to the variable m. So easy that way. Now there is this another command or another function which is called seek, which is short for sequence. So let me run this and I'll tell you what this. Okay. Mm -mm -mm. Mm. I think I've forgotten how seek works. So if you forget what a command works and what arguments you have to give to that command, you can do this option. You can do a question mark followed by the name of that command. And when you run it, so now you see here in the bottom right pane, there are multiple sub panes here. So it's called files, plots, packages, help, viewer, presentation. So we'll be mostly focusing on plots and help, but we'll be exploring the other options a bit as well. Okay. All right. So yeah, so what seek is doing is that there are going to be these 3 arguments here, a from, a to, and by. So if I want to go from 10, let's say I want to go from 10 to 30 in increments of 2. So this is what I'm going to write. From 10 to 30 in increments of 2. And if I run that, so now you can see here what n comes is that I have 10, 12, 14, so on and so forth. And I can just type in n here in the console. And when I run that, you can see I get this vector as the output. So again, you see here, even though it's a vector, here in the output, you only see the number 1. Why is that? Because that line is beginning by the first element of the vector. Now, in case if this was, let's say if this was 60, okay, if it was a longer sequence from 10 to 16 increments of 2. And then now if I run n, so now you can see what's happening here is I have 20 elements in the first line, and the 21st element of that vector comes up in the second line. So what this square bracket is telling us is the element position, or I should say the position of the first element of that row. All right. So this vector itself is a 26 element vector, of which 20 are in the first line and 6 are in the second line. Okay. And you can also have a mixed vector wherein some elements may be numbers, some may be character. Now, again, a question. So here you can see a vector is either a character or it's a number. If it's a mixed set, which of the two do you think this vector would be called and why? Again, you can just give it a try. It's okay if the answer is wrong. It's a new topic for all of you. So just try. What do you think the output could be? So again, if I run this line, I would get that vector here in the environment. So what do you think the type of vectors would be? Would it stay numeric? Would it stay numeric or character? Or would it not run? Would I get an error already? Or would I get a warning? What do you think would happen? Character? Yes, that's right. Okay, so it's the same thing. So you have two data types here. You have character and you have numeric. You cannot have two data types in a vector. You need to have either. So either you convert the numbers to a character, you can convert the character to a number. Now we saw already a few minutes ago that converting character to number is not possible. But you can convert number to character. You lose their value, right? Now here you could have added this 1 and this 3. But now when I run this, now you see here what happened is now they're no longer 1 and 3. They're double quotes 1 and double quotes 3. So now they are no longer numbers, they're characters. It's character 1 and it's character 3, just like it's character A and character B. Okay. Sorry. Yep. Okay. So they are no longer numbers. You cannot do any mathematical operations on them, but that's okay. 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 The next. So now let's say you want to add some elements to the end of another vector. So let's say here L, you already have 8 elements here. I want to add a 9th element to it. So what I can do is, okay, before we go there, if I want to access any element from L, let's say I want to access the third element. Okay, what's the third element? That's 5. So what I can do is I'll write L and I'll write the square bracket. And you will see here when I typed the starting square bracket, the ending square bracket came on automatically. Because obviously if I'm starting a bracket, the ending bracket has to be there somewhere. So R automatically does that. So it's just very convenient. So, okay, so I have L and I type this square bracket and I wanted the third element. So I'll just write 3 here. And if I do that, I get 5 as the output, which is correct. My third element in the vector L is 5. Okay. I can also access multiple elements. Let's say I want to access both second and third element. So I get both of them, right? The second element was 6, the third element was 5. Okay, can anybody tell me if, or rather, how to access elements 2 and 4 from vector L. What do you think I should write? So this is a very important question. Um, because yeah, this is important. We will be building up on this notation, what we talk about now. We will be building on that in the upcoming weeks. So this is very important. Oh, okay. Correct. So if you access both of them separately, that's right. Um, but we will get two different outputs, right? So it's like L2 and L4. But what if I want both of them together? What if I want, so I should say, how to create a subvector containing elements 2 and 4, elements at positions 2 and 4 from vector L. Let's say something like that. Okay, so I can also adjust this pane here. Uh, you are almost correct. Another one more try. Anybody? So again, so let me give you a hint for that. So the question is, you want to access elements from the vector L. So the first thing you write is L, and you want to access some elements, so you have to write the square bracket. So this is definitely going to be there. Now, whatever you want to access, it's all going to be inside the bracket. Okay? So something needs to be written inside the bracket. What is that? Why did you write 2, 4, 2? Why 2 twice? Uh, no, I mean, you want to access just 2 and 4. Oh, interesting. Hmm, that's a good suggestion, and you're almost there then. Okay, so let me tell you an easier way. So I can sort of give you as a homework. You can try how what you did can also work. But okay, cool. You are all almost there. Okay, so what 2:4 is going to do is going to give you elements 2, 3, and 4. You're going to get 3 elements as the output. We want just elements at second and fourth positions. So here we need to make, so we could have just written 2 comma 4, right? But R is going to say, um, so it's going to consider, so this might sound a little confusing, but try to understand. So a vector is a one-dimensional sequence. Okay. When you're talking about tables, they're two-dimensional. So you also have rows. I mean, you have rows and columns. So when you're writing something like a comma, the first part is to access rows and the second part is to access columns. An array, or sorry, in this case, a vector, there's no row or column. So what you need to do is you need to create a vector of the positions that you are interested to access. So these are the positions you want, 2 and 4. Okay, these are the element positions. And these element positions are to be extracted from the vector L. So if I run that, then you see you get the second element, which is number 6, and you get the fourth element, which is number 9. Okay, try to see this. Um, we can discuss this a bit more if it's confusing. Let me know. But the way we are building this is there's a vector you want to access. So you write the vector. In this case, it's L. You have to access something from L. So you have the square bracket. And you want to access some positions. So those positions have to be written in a vector as well. So vector is nothing but a combination of numbers. Okay. So you are combining 2 and 4. So that's exactly what you're doing. Using the C function, you're combining the numbers 2 and 4 in that order. And that's it. Okay. So if this is clear, I'll move on to the next thing. So we just saw here that this vector L that we have been talking about has 8 elements right now. Let's say I want to add a 9th element to it. So I can just directly write that 50 and assign it to the 9th position here. So now, right now you see it has 1 to 8. And if I do this, it just moves on to 1 to 9 and this 50 is added at the end. Now you can ask, this was continuous. Okay, there were 8 elements. I put in the 9th element. Now there are 9 elements. What if I put in an 11th element here? What if I just skip the 10th element? What do you think would happen? So let's say I want to assign the number -3 here and I want to put -3 as the 11th element. What's going to happen? Again, so this, I also don't know the answer. It just came up. I just thought, what would happen? Any ideas? Would you like to guess or should I just run the command? Any? Okay, let's try. Let's see what it gives. It should erase the previous one. Okay, let's see. Oh, so now you can see what it did was, so you see here, there were 9 elements. The 10th element was NA and the 11th element was what we wanted. So it did not erase anything. So we have 9 elements at the moment and we say we want to assign something at the 11th position. So we are just skipping over the 10th position. So there was nothing on the 10th position, which is exactly what NA also shows us, that R did not know what to do with the 10th position. So it's all NA. Okay, so it's just a random practice. And for R, the best thing I can recommend you is to practice. You don't have to necessarily install RStudio, but RStudio is slightly convenient in some cases. So if you can, I will recommend that. But either way, practicing is definitely going to help you, either platform. If you add a number, okay, that's a very good question again. So I would not call it adding the number, but instead we would be replacing a number. Okay. So now currently, let's say currently the 5th position was number 13 here. Now if instead I write 5 as 10, if I say assign the number 10 to the 5th position, now you see that's got changed. Now, if you want to add a number in the middle, it's not going to be very straightforward. So we will not discuss this in detail right now. But what we can do is that you can basically split your vector into 2. So let's say you want to add something at the 5th position. So the first 4 positions stay the same. So you make a small vector with the first 4 positions, and then 5th onwards, you have another vector. And then you're basically combining 3 things: the original start, the middle number that you want, and the end. So you've inserted a number in the middle. Does that make sense? Yeah, okay. But yeah, these are all very good questions. So again, the best way to find the answer is to try it. Okay. Now, one final way of adding a number is again through the combine function. So the combine function is literally combining 2 things. two or more things at a time, right? So if you see here what it was doing right now, it was combining all of these individual elements in that order. That's what the combine function is doing. So now if you combine a vector with a number, it will just combine. So that vector also was a combination of numbers. So now you have another number added at the end. And here what I'm doing is I am um or rather I'm overwriting the name here. So I called it L. So just to show you, so L was this thing, this 11 element thing. If I just run the right half, I'm just highlighting that if I'm running only that, you can see that 60 is added at the end. And now what I'm doing is I'm calling it that save it back into L. So this L had 11 numbers. If I run this, so this L now has 12 numbers. I'm overwriting it. Overwriting is something you should be very careful with, because once you've overwritten a variable, you can't go back to the original. There's no undo here. Okay, so that's important. You can undo when you're typing here, but once you've run a command, you cannot undo. Okay. Um, okay. Okay, yeah. So this is we've just been talking about how to create vectors and subvectors. So just to remind you, L no, so N. So N is numbers, K is alphabets. Now, if I write the number vector N, the numeric vector N, if I say that vector plus 3, what do you think is happening here? What the output is going to be, or what is happening with this line? So I have numbers from 10 to, I think, what, 30 or something, or whatever numbers are there. So this is N. Yeah, I have numbers up until 60, 10 to 60. And I'm saying N plus 3. So yes, it's going to be added to all. That's perfect. Okay, so if I'm running that, so you can see each number is now increased by 3. Great. And now if I do the same thing on a character vector, what do you think was going to happen? If I say A plus, or rather A minus 4, what's going to happen? Error, warning, NA. Okay, let's just give it a try. So it's going to say error. So it says non-numeric argument to a binary operator. So the binary operator is subtraction, right? Subtraction accepts two numbers at a time. So it's a binary operator. And you give a non-numeric argument. You gave a character argument. So it says error, which is expected. Okay. All right. So we have scalars. We did simple mathematical operations on scalars. We have these vectors. We discussed a bit about making vectors, subsetting. So subsetting or making a subvector from a vector, combining things, and doing some very simple plus minus on vectors as well. Now, there are lots of vector operations that we can do, but we are only talking about simple plus and minus for today's class. So if I'm saying, okay, let me give you another example. Let's not use these. So let's say, yep, that's the right error that you're getting. So that's exactly what I also got. Error in k minus 4, non-numeric argument passed to a binary operator. Because adding or subtracting something from a character does not make sense, right? Okay. All right. So let's say I'm just defining two vectors right now. Okay, so we already have this vector m, which is 3, 4, 5, 6. Let's say I also have a capital M vector, which I'm saying, let's say it's minus 2, 0, 4, minus 10. Okay, so I have these two things. Okay, both of them have 4 elements. Now one of them does come up as an integer, int, but it's numeric, right? It's just that it's an integer. Don't get confused by anything. It's still an integer. I mean, it's still numeric. So both of them have 4 numbers, both the vectors. So I can do a m plus n. If I do it m plus n, what's going to happen? So it's going to add element wise. So 3 gets added to minus 2, 4 get added to 0, 5 to 4, and 10 and 6 to minus 10. Oh, wait, sorry. Yep, this one. So it's this thing, right? So 3 and minus 2 give you 1, 4 and 0 gives 4, 5 and 4 give 9, and 6 and minus 10 give minus 4. So that's cool. Now the other example that I just ran here was m plus n. So now you see here, m is okay. So m has 4 elements, n has 26 elements. So one is longer than the other. So what happens here is, maybe I can draw this thing here. You can still see my screen, right? So let's say if I have, let's say, if I have 1, 2, 3, and 4, and I have another vector, which is 1, 2, 3, 4, 5, 6, 7, 8. Now, if I say I need to add these two things, what's going to happen is one gets added to 1, so that gives me 2. 2 to 2 is that gives me 4. Okay, 3 and 3 give me 6. 4 and 4 give me 8. And now what happens is these numbers still remain. So the shorter vector is going to be repeated. So I get 5 and 1. That gives me 6. 6 and 2. That gives me 8. 7 and 3 gives me 10. And 8 and 4, that gives me 12. Okay. Now let's say if there were 2 more elements here. Let's say if there was a 9 and a 10 as well. So now what's going to happen? Again, it's going to recur. So 9 gets added to 1. So that's 10. 10 gets added to 2. And that's 12. And that's it. You don't have the longer vector gets over. Okay. So what is happening here as well, when you have a shorter vector which has just 4 elements and you have a longer vector which has 26 elements. Now 26 is not a multiple of 4. So you can see here, when we did m and n, when we added m and n, 3 gets added to 10. So you get 13 here. 4 gets added to 12. You get 16 here, and so on. But this happens until, let's say, element 24. And then for element 25 and 26, you still add 3 and 4. But then these two are not, so 26 is not a multiple of 4. So you can see this warning message. The longer object length is not a multiple of the shorter object length. So you get a warning, but it still works because you're still able to add. However, this is important, that you should, whenever you're doing addition of two vectors or subtraction of two vectors like this, always be careful that their lengths should be the same. Or at least they should be multiples of each other if you want this recurrent thing to happen. But it's still, in most cases, you would want them to be of the same length so that it's a 1:1 thing that's happening. Okay. Likewise, if you have L and N, since these are also, it's the same thing. Okay, I just had like this different example here. So there's no point in getting confused. Now L and K on the other hand, if I do that, then you can already see that it's the same thing. Since you have a character vector, this step is this is not going to work. It's going to give you an error, right? So not new. And this is something that we already saw, right? If you want to make a subvector, how do you make a subvector? So we already saw this here. Okay, so it's the same thing. Okay, so again, the script that I have, it's to give me a sort of an idea of what all to discuss, but you can always keep changing it. And then you see this asterisk next to the name. It means that the script is updated, but it's not saved. So I'll just press a Control S and the script gets saved. Okay. Um, so this is something which we talked about a bit. So capital all caps lock true and all caps lock false, as well as the capital T and capital F. These are all reserved words. And the number that these NA related things, so there's capital NA, there's null, which we haven't discussed yet, and there's NaN, which stands for not a number, and there's infinite with a capital I only. So these are all reserved words. So you should not use these as names of your variables. Okay, they have specific meaning to R. So R recognizes these specifically. Okay. So yeah, there were just a few more miscellaneous things that were discussed in the week. I couldn't find a better way of putting it, so I've just put it under miscellaneous commands. So you remember last time we talked about help.search, help.start, these commands. So there was one more in them, which is called the R site search. So R also has a site. Okay, so let's just try and run this. So you see when I ran this, the R's website ran and it's opening up a page here. So it's basically opening up. If I would have typed data input directly into this page, what all would it give me? So again, um, it's a good idea to know that you have all of these options to search for what you're looking for from within R. But of course, you can also search this online, right? You can directly search this in any search engine, but it's also possible to do it from within R. Um, there was this bar plot command that was discussed. Um, mm, 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 mm. Okay. Um, so again, there would be there would be like dedicated weeks where we would be talking about making these plots. But for now, let's see what is happening here, just to give you an idea of how R is working. So first of all, what you can see here is there are two brackets we are talking about. It's like a nested one within the other. So this is one set, and then this is outside. So this is like the major command. So there's bar plot, and within bar plot there's another command. So L, we know what L was. L was this vector as a number vector. Sorry. And then now what we have is there's a command called table. So let's see what this is doing. So what the table command does is it gives you the frequency of each element. So how many times? So something like when you calculate mode, okay, you might be familiar with how mode is calculated, right? So it's the number which has the most occurrence. So to find out the number with the most occurrence, you should calculate the occurrence of each element or each number or each type of each unique element. So this is what this is doing. So it says -3 comes once, 2 comes once, 3 comes once, but the number 5, it comes twice. So it's here and it's here as well. So there are 2 occurrences of 5. And so this is the table that you've made, right? Now, with this frequency table, you are making a bar plot. So I'm just running this so you can see what's happening here. Another interesting thing to note here is that it just ignored NA. Okay. There's no occurrence of NA, which is what you would mostly do, right? If you have a list, I mean, if you have like a set of numbers and all that, you're not interested in missing values normally. Okay. Again, there are lots of ways in which you can incorporate missing values and all, but we'll not be going there. That's not the main purpose why we're talking about this command right now. So the main idea is this sort of a nested command is that you're doing one sort of a calculation, or you're, you know, finding out something, and then you're feeding that as the argument or as the input to another command. So this is what is happening here. So the frequency of all numbers was 1. So this is where the bar is, but the frequency of the number 5 was 2. So this is where the bar is. All right. And just to note, so you can shift this thing here and there, and you can see when it was big enough, you could see all numbers. But when I squished it a bit, some numbers got missing here because there was not enough space to write them. Um, can you tell me what O is there? What's the vector O? Is it a numeric vector, or actually it shouldn't matter. Could be a number or a character, anything.
Yes, it's a
Hello.
number only. 3,
Uh,
7, 10, 13.
okay, can you okay, can you wait for 5 minutes, and then once I'm done with a few commands, would you like to share your screen and then we can see what's not working?
Okay, okay.
Okay, so just give me a couple of minutes. I have a few more commands to discuss. All right. So, okay. Now, right now we have not talked about the importance of the directory, but you can see here that there is a certain path written here. So in my documents folder, I have a lot of folder within folder within folder, and somewhere I have this NPTEL folders, and then I have a folder for this week. So this is where I've saved my R script. So there's something called a working directory in R, and this is mostly important when you are going to be reading some data or you're going to be saving some data. So let's say I made this plot. I want to save this plot. Or if I made a table, I want to save that as an Excel file, or I want to read an Excel file, which we will do eventually. But for all of that, that data should be, so that data could be anywhere on your computer, but that folder where that data is, it should be accessible to R. So you should tell R where that data is. So that's where R should be present. So that's called the working directory, so WD for short. So if I just type get WD, that's basically telling me get me the working directory, tell me what the working directory is. So it's nothing but this path that you see here. Okay. If you don't see a path here, then you can just directly write get WD and it'll give you this path. If I want to set the working directory to something else, so I need to type that. So let's say I can type, for me, it's going to be users, and then I can press a tab here. It's going to give me all these options. So I'm pressing a tab again. Let's say I want to save something in downloads. So now just see if when I run this, my path here is going to change. So if I run this, so you see that got changed. And now if I run get working directory, it changed. Okay. So I can set the working directory. I can get the working directory to see where we are right now. And I can set the working directory to change the working directory. Okay. There is the ls function. It's short for list. List is important when you want to see what all variables are there in your environment. So it's basically a list of these things, right? Now you can appreciate that since this global environment, this environment pane was not there in R, the only way you can find that out is using the ls function. But here in RStudio, since you already have this environment, the ls function may not always be useful, but we'll see its use just in a few minutes. Now, what you can do is you can also remove some variables. This is something I would not recommend you to do in general because, like I said, there is no undo button in R. If you remove a variable, you will have to remake that variable from the start. Okay, but you can still remove it. So let's say we had this small x here. So if you want to remove it, I'll just write rm, which is short for remove, and within bracket, I'll write x. What happened here? Okay. Just ignore the warning message from now. The warning message was because my um this drawing was smaller. So you can ignore that warning message. It's not going to come on your computer. I can also remove multiple variables together. So just see what we are doing here. So the list, I'm saying the input is, I'm calling the input as list. So we'll see more of this later. But your inputs can have names. Can we make a bar plot of infinity? I'm not sure if we can, but we can give it a try. But most likely it should not work. But good question again. Give me a couple of minutes and then we'll just see. So what we're doing is we are basically deleting or removing these three variables. Okay. And we are making a combination of these variables. We are combining these three and feeding that into the RM function. So if we do that, object A not found. Okay, so I don't have the object A here. But yeah, the others are removed. X and capital X and Y are removed here. Um, this is just more confusing. And if I want to remove everything that's here, okay, there's no point in me writing down these individual names. So what I'll do is I'll just write ls, and we just saw what ls does. It gives me the names of all the variables. And just keep in mind, when it's giving me the names of the variables, it's giving me in double quotes. But that's okay. So that's why we also had double quotes here. So what we're doing is, so instead of us making this vector on our own, we are using the vector that's returned by the ls function. And we are feeding that into rm. And when I run this, you'll see that my global environment becomes empty. It's empty. Okay. There was also this, you can see this broom symbol here. So it does the same thing. It clears your environment, remove all objects from the environment. But again, use this cautiously because once it's removed, you cannot get that back. You'll have to rerun the commands to create the variable. And likewise, you also have a broom here. So you can clear the plots. If I say yes, then it's gone. You also have a broom here, which clears up this. It does the same thing as the control L command. So, yep. So the question was that if can you make a bar plot of infinite? So what we can try to do is, so let's have a variable t, and let's call it 1, 2, 3. So let's say this is my vector. Okay. So this is my variable. This is my vector. Now the thing is, um, mm, okay. So when we made this bar plot, they were actually bar plot, like the bars were representing the frequencies. So if I do the same thing here, if I do bar plot of the frequencies of this, so now here infinity is an entry. Infinity does not hold the value infinity here. We are talking about the frequency of infinity. Now, how we are going to plot infinity itself is a different question. And if you can hold on to that until the time we talk about making plots in R, then that will be nice. Otherwise, feel free to give it a try. I myself haven't tried plotting infinity ever. Um, but give it a try, and if not, then you can put this question on the discussion forum. So you know that there is a discussion forum here. in NPTEL here, there's this Q&A option. So you can go there. It's going to redirect you to a group, and you can put on your questions here. Okay. Okay. So this is the commands that we wanted. I have a few questions that are very similar to what your assignment is going to do, what your assignment is asking. So it's going to be a good practice. But before we go there, could one of you who had that error, could you share your screen? And then we can see what the error was. Dr. Raman, could you share your screen? I don't think he's in the meeting, right? Oh, okay. Anyway, so then let me just reshare my screen. Okay, the screen is loaded. And okay, so we have some practice questions. Now, these are questions. So please definitely type in the answers or unmute yourselves. Okay. Yes. So which of the following is used to search the web for information and answers about the keyword mean? So you can see here, it's either a capital or a small thing here in the name of the command, or it's about there's being a double quote or not. So which of the options is correct? C option is correct. Great. So R and S and the other S, they're both in capital, they're all three in capital, and mean has to be in double quotes. So most often, whenever you have names of anything, most often they would be in double quotes. Okay. Okay, so this is the format of the next few questions. So you need to you basically need to tell what's the output of what. So when X is 20 and Y is 20 but in double quotes, which of these two will give a true or a false answer when you run the command is dot character? So is dot character X, it's true or false, and is dot character Y, whether it's true or false. You can just unmute.
So
Yep.
yeah, hello. So for the first one is the character X. That would be false because it's numeric, and for
Perfect.
the second one, it would be true.
Perfect. Great. Right. So just to shorten this up, I'll just write F here. I don't have my pen today, but yeah, okay, this is true. Okay, great. And then it's just the opposite. So X numeric. So okay, it's
Yeah,
simple.
it's the way
Yeah.
it's like.
Yeah. Okay, perfect. Cool. So we talked about this. What's the mode of these two? Again, you've you want to
Again, it
unmute.
would be the cross. Yeah.
Yep. Okay, so this is going to be numeric. So yeah, I'll just put the arrow here. This is this one and this is this one. Okay. Okay, this I think we did not discuss. So let me quickly give you a demo. So we talked about mode here, right? There's something similar, but slightly slightly different. So we talked about mode of X and P, that's numeric and character. And then there's storage mode. So you see for character, when the mode is character, the storage mode is also character. But when the mode is numeric, the storage mode is double. So double is it's like it can also include decimal values. Okay. So again, this is not super important, but you should just know that double or integer, these are, or float, if you've heard about these are storage modes for numbers. But again, they're not like, don't get bugged up over this technicality. All right, so again, it's like this. Yep. And now this one, when you have x is 20 and y is 20 plus infinity. Oh, what would it be for a sequence? That's a good question. So let's give it a try. So we had some sequences here. Let's rerun those. Okay, so let's take these two examples, L and K. So mode of L, that's numeric. Mode of K, that's character. Storage mode of L, that's still double. And storage mode of K, that's still character. So it's still behaving the same way as it did for single elements. Okay. But yeah, all good questions. So yep, keep shooting these questions. Okay, so again, this question. So x is x finite? Is y infinite? Which of them is true?
Both of them are true.
Both of them are true. Good, good. All right. Okay, now we have this. What is the output of this question? Again, so it's just that, okay, I realize I've put in a very complicated number here. But anyway, okay, so for this question, we can definitely directly go into R and check the answer. But a very important thing is that in your final exam, if for those of you who are registering for the exam is going to be a multiple choice or a single value answer type question. And you would not have access to R or RStudio that day. So the thing is that questions like these, you would still have your calculator with you. So an online calculator would be accessible. So rather than going into R and solving this, first give it a try by using a normal calculator and see what answer you get. And then of course go and double check in R. So that also serves as a practice for coding in R. And then you can see if you get the same answer. And then you can be sure that what answer you've got is correct. Okay. So for now, we can let me have both of these things side by side. Okay. So I'm just going to I'm typing this here directly in the console. So x is equal to 43. You can ignore this comment here. So okay, the comment here was that you can see that the figure margins are too large. So when you don't have enough space for the figure, it often shows this error, but you can just ignore it for now. We'll discuss this in more detail when we are talking about plots and everything. But okay, for now, okay, give me 1 second. I'm just going to erase this figure. You sure? Yes. Yes, please. Okay, done. Okay. Yeah, so this is both the convenience and inconvenience of RStudio. So if I write x is equal to 43, what is happening? Okay, and then I write y is equal to x to the power 3. Then you can see here, so it calculated this value, x is 43, y is this large value here. And then z is equal to y to the power 2 plus x to the power 4. And basically we want to find out, so what we want to actually find out is the output of z. Okay, what's the output of this? So output of z is this large number. And since it was following BODMAS, so first we calculate y to the power 2. We also calculate x to the power 4, and we just sum these two numbers up. And this is what the number is. So again, it's Alrighty. Okay. What do you think the output of this is? So the first thing to check here, just as a sanity check, is that we're talking about, so we have vector divided by a number, and then we have another vector divided by, or like multiplied by a number. So these two, so the first vector here, so that's going to give us 1.2, 1.3, 1.5, 1.7. The second vector here is going to give us 12, 13, 15, 17. And then we are summing up two vectors. So here it's important to check what the lengths of both the vectors are. So in this case, it's 4 elements and 4 elements. So that's good. So you're basically summing up 12 plus 1.2. So that's 13.2. 13 plus 1.3, that's 14.3, so on and so forth. So C option is correct. Okay. I hope that made sense. Okay. Okay, yeah, that's all then. So the session was recorded. I will upload the recording on YouTube. You will get the link on that Google Sheet. This PPT is going to be uploaded to that Google Drive. Our script will also be uploaded to the Google Drive. And for the first 2 weeks, your assignment deadline for both the weeks is the assignment deadline for both the weeks is the coming Wednesday. But for then on, afterwards, it's going to be every week. So do remember to submit your assignments, especially if you are going to appear for the exam. But even otherwise, submitting the assignment and getting these scores is a good check on how much you've understood for that week. And if ever you feel that there's any question which is incorrect, or if any options are incorrect, please put it in that Q&A section, and one of the TAs is going to answer your query. Okay. So again, there will be another session on Tuesday for week 2. So in case you still have anything to discuss, you can attend that. But otherwise, for week 3, the sessions are going to be, for the Friday session is going to be on 9th of August. And the Tuesday after that is going to be also for week 3. So you can attend any of those. But I'll be here next Friday. Same link. Okay. All right, I'll just stop sharing my screen. And thank you for attending the session. I'll see you again next week then.
Thank you.
Yep. All right. Bye-bye. Good night.
Thank you.